Today's lesson we are going to look at Lewis dot diagram or Lewis structure. Lesson 101. Let us start. This lesson we are going to look at the basics of Lewis structure. In order for us to answer questions which are much complicated, we need the basics. On our periodic table, we know that this will be group number 1, this will be group number 8, this will be group number 2. So the first element is hydrogen, then this one will be helium, then we have lithium, we have beryllium, and then we have neon here. Now Lewis dot diagram, it represents a lot of things. It represents the group number which an element belongs, and then it also represents the valence electrons. Now before we look at Lewis dot diagram, we need to look at how to represent electron diagram. Now for helium, we know that it has 1 electron because it's element number 1, its atomic number is 1, so it has 1 electron, 1 proton. We look at lithium, it's element number 3. Remember the first energy level or the first energy shell, which is this one, it can only occupy 2 electrons. So since lithium is element number 3, it will have 3 electrons. So the first energy level will have the maximum electrons, which is 2 electrons, and then we jump to the next energy level, which is the second energy level, will only have 1 electron. So all in all, we have 3 electrons on lithium. Let's go to magnesium. Magnesium is element number 12. It means it has 12 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need to draw another energy level. Remember, energy level number 2 and 3, they can only occupy the maximum of 8 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you understand this, it will be simple. When we talk about valence electrons, we are talking about the electrons on the outermost energy level. So looking at hydrogen, when we draw the Lewis structure of hydrogen, we only consider the valence electrons. So hydrogen only has 1 electron on the outermost energy level, so its Lewis structure will be like this. Now going to lithium, we can see that the outermost energy level, it only has 1 electron, so it's lithium, and then it will be like this. For magnesium, we look at the outermost energy level, it has 2 electrons, so the Lewis structure of magnesium will be like this. Now I want us to look at the relationship. You can see that hydrogen and lithium, they are both in group number 1. So we can say all the elements in group number 1, their outermost energy level only occupies 1 electron because they're in group number 1. Magnesium is in group number 2, it will have 2 electrons. And then we look at helium. We know that helium, originally it belongs here. That is why it also has 2 electrons on the outermost energy level. Now elements in group number 8, like neon, it will have 8 electrons. So its Lewis dot diagram would be like this: 1, 2, 3, 4, 5, 6, 7, 8. It's in group number 8. It has 8 electrons on the outermost energy level. We look at oxygen. Oxygen will have 6 electrons on the outermost energy level. We look at fluorine, group number 7, so it will have 7 electrons. Calcium, it's in group number 2, so it will have 2 electrons. Carbon is in group number 4, so it will have 4 electrons. So these are Lewis dot diagram for elements. Now suppose we want to draw Lewis dot diagram for compounds. How do we actually draw the Lewis dot diagram? Suppose we have hydrogen bonding with hydrogen to form this. In terms of Lewis dot diagram, we are going to have something like this. In order to understand this reaction in detail, we need to understand the octet rule. Oftenly elements bond to reach the octet rule. In simple terms, to be the same as elements in group number 8, remember these are noble gases or ideal gases. So all the elements, they bond such that they can reach the ideal state. Now ideal state, it means an element must have valence electrons which are 2. Remember, since helium is an ideal gas, and then its valence electron is 2, so hydrogen will try to be the same as helium. Since hydrogen, it only has 1 electron. In order for it to be an ideal gas, it will try to bond with another element to reach the octet state, or the valence electrons to be 2, such that it becomes the same as helium. So in this case, we can see that a single hydrogen atom only has 1. It's running short of 1 electron so that it reaches the octet state. So bonding with another hydrogen, it becomes ideal, or it becomes noble, or it reaches its octet state. Now counting the number of electrons for the first hydrogen, we are going to have 1, 2. It's 1, 2 electrons. So you can see that it has reached its octet state, and then counting for the second one, we are going to have 1, 2. So both of them, they have reached the octet state. Let us look at another examples. Remember, our focus for today is the Lewis dot diagram, so never mind the subscript of these elements. We are going to have something like this. Now hydrogen is in group number 1, so it has 1 electron. And then chlorine is in group number 7, it has 7 electrons. So it's 1, 2, 3, 4, 5, 6, 7. So 2 octet states. Valence electrons 2 or valence electrons 8. So when the 2 bond, we are going to have something like this. It's 1 electron from hydrogen bonding with 1 electron from chlorine, then chlorine. So looking at hydrogen, it has reached its octet state because it has 2 electrons. Now looking at chlorine, it has also reached the octet state because it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Sometimes it is represented like this. It will have those 6 electrons, and then the bonding is represented by using this stroke. Let us quickly look at the Lewis dot diagram of H2O. So we are going to have oxygen and 2 hydrogen. So oxygen has total number of 6 electrons. It needs 2 electrons to reach its octet state, and then hydrogen has 1 electron. So this is what will happen. This one will bond with this hydrogen, this electron. Then this one will also bond with this electron, and then we are going to have something like this. Now counting the number of electrons for hydrogen, the first one we have 1, 2, it's okay. The second one 1, 2, it's okay. And then when we count for hydrogen, we have 1, 2, 3, 4, 5, 6, 7, 8. We can also draw it like this. Now what happens when oxygen bonds with oxygen to form this? How can you draw the Lewis dot diagram? We know that the first oxygen and also the second oxygen will have six electrons. Also this one 6 valence electrons, and then when they share 1 electron, we are not going to have 8 electrons. Instead we are going to have 7. So in this case oxygen will bond with 2 electrons. So we are going to have something like this. In order for us to obtain 8 electrons, we need to bond the 2 with 2 electrons. So it's 2 electrons from each element. Now in this case we can see that the first oxygen has 1, 2, 3, 4, 5, 6, 7, 8. The second one has 1, 2, 3, 4, 5, 6, 7, 8. And then we can also draw it like this. It will be 1, 2, 3, 4, 1, 2, 3, 4, and then this represents double bond. That's it for this lesson video. Remember, this is the first lesson video, which are basics. Do watch the second video, lesson 102, based on Lewis dot diagram, whereby we look at more complicated compounds and ions. This is Bahula SG. Thank you very much.